this is what you're giving in a FE handbook on ellipses. And of course, you're going to have this available on the exam as well. You're giving the equation of an ellipse, which is right here. Okay, and then you're giving a bunch of information on the eccentricity formula, the how to calculate B when you have A and E, and then focus coordinates, and then how much is the directrix. And I want to add a few more information that are not giving in the FE handbook and that are very important to know. So if the ellipse has or is centered at the origin, the equation is going to look x squared over a squared plus y squared over b squared equals to 1. And if an ellipse is centered at, let's say, -3, 7, the equation of an ellipse is going to look like this. X, we have minus from the formula over here, and then -3, so it's going to be +3 squared over a squared plus y -7 squared over b squared equals to 1. So just pay attention to the signs, right? Another thing I want to point out is, so this is the A, and this is the B we're using in the formulas, and A is also called the semi-major diameter, and B, it's also called as semi-minor diameter. And then this, the big diameter, it's called the major diameter. And the small diameter, it's called the minor diameter. Great. Here where the major diameter ends, these 2 points are called vertex. And these points where the minor diameter ends, it's called co-vertex. An ellipse has also 2 very important points called foci, and they have a property that we're going to discuss further. This is called the focal distance and is the same as this distance here. So let's talk about these 2 focal points and what do they represent. The property of these focal points is that if I take a point, any point on the ellipse, absolutely anywhere in the ellipse, and I draw these 2 distances from that point to the 2 focal points, and I call this D1, if I call this D2, D1 plus D2 is a constant. What I mean by that is, let's say I take any other point on the ellipse. Let's say I go ahead and take this point over here, and I will do the same thing. Let's say this is D3, D4. And just for the sake of it, I will just go ahead and take another point because I really want to prove my point here that, where should I choose it? Just anywhere on the ellipse. It can be here, it can be absolutely anywhere. And if I choose this point over here and I draw the distances from the focal point to this point, and let me say I call this D5, D6, and I can do this on and on, then the property of these 2 focal points or foci is that D1 plus D2 equals to D3 plus D4. So the sum of these two distances is a constant, right? D5 plus D6 plus, and we can go on and on. I do dn minus 1 plus dn. Okay, so this sum of these two distances is a constant. So now let's do something else here. We know that the focal points are at the equal distance from the center, which means that this in yellow is equal to this part here in yellow. And let's call this to Q. And then let's also take this distance in purple, the purple distance. And let's call this distance, I'll call it P. Let's just call it P for the sake of it. So if you think about it, how much is P plus Q? P plus Q is equal to, so P plus Q is equal to the major diameter. And major diameter is equal to 2A, right? Because A is the semi-major diameter. This is A. And P plus Q equals to 2A. Next, let's imagine how this point, that if I take, imagine that I take this point and I bring it all the way to the vertex here. Let's see what happens to D1 and D2 if I do that. So if I take that point and take it all the way to the vertex, imagine how D1 is going to become Q and D2 is going to become P. So if I drag this point over here, D1 is going to be equal to Q and D2 is going to be equal to P. So what does this mean? This means that from here, D1 plus D2 equals to what? If D1 equals to Q and D2 equals to P, then we know P plus Q equals to 2A. That means that D1 plus D2 equals to 2A. And there you go. We just found out that if you go anywhere on the ellipse, any point on the ellipse, and you connect that point to the foci, then you get two distances. And the sum of that distance equals to 2A. And this is true if you go to any point on the ellipse. And now let's see, how can we use this to calculate the focus points, the distance of the focus point. So I'll go here and I'll draw my foci. Let's choose this point over here, a point on the ellipse. So I know I'll draw the distances from that point to the foci. And I know this is D1 and this is D2. Of course, this in green is B. This magenta color is A. Let me put it, so this is A. And this is the focal point that we want to calculate. So based on the fact that D1 plus D2 equals to 2A, let's see what can we figure out from here. This triangle, D1 and D2, based on the way it's built here, it's very obvious that it is an isosceles triangle. D1 is equal to D2. So if D1 is equals to D2, that means that this equals to A. So in this case, D1 equals to D2 and it's equal to A. correct? So now we have this right triangle over here. We have a side, we know a side, we know the hypotenuse. We can calculate the other side. So from this right triangle, f is going to be equal to hypotenuse, a squared, square root of a squared, square root of a squared minus b. And here we go, we have just found out the formula of the foci. And just one little note here, in case your ellipse looks like that, all you have to do is just plug your distances here. Always remember the foci are always situated on the major diameter. It doesn't matter if your ellipse is like this, horizontal, short and fat, or tall and skinny. The foci points are always situated on the major diameter. And this is going to be A now, correct? And this is your B distance. And then if we draw the distance from the foci to this point on the ellipse, this is going to be your focal point. And now this is going to be your B. So in this situation, focal point is going to be equal to B squared minus A squared. So just so you know, the focal distance is, you're using the same judgment, but then when the ellipse is tall and skinny like this, you just plug your data and you'll find that it's the other way around, b squared minus a squared. Just something for you to keep in mind. Now let's solve a few examples. Write an equation for an ellipse centered at the origin, which has foci at plus minus square root of 8, 0, and covertices at 0 plus minus square root of 10. So based on what we're giving in the problem, we know that focal distance is square root of 8, because the coordinates, we're giving the coordinates, so I'm going to just plug this in. This is square root of 8, 0, the coordinates of this point, and this is minus square root of 8, 0. So this tells me that the focal distance equals to square root of 8. And then I'm told that covertices are at 0 and square root of 10, plus minus square root of 10. So this point has the coordinates of 0, 0, square root of 10, and this point has the coordinates 0 minus square root of 10. And what this tells me is that B equals to square root of 10, and this is because this distance, let's show it here, is B, and we know that this distance is A. So we have to find A in order to write the equation of an ellipse. So we're going to use the same thing we just discussed about the focus point. I will connect, let me get another color to make it more interesting. I'll connect these 2 points here. So what we know is that this distance is B. This is the focal point, right here, the focal point. This is B. We have to calculate this hypotenuse. And this is as simple as using the Pythagorean theorem. And we know that this is the A distance from the fact that D1 plus D2 equals to 2A. This means that D1 equals to D2 equals to A. And this is D1, D and equals to A equals to D2. So let's use the Pythagorean theorem. A squared, it's going to be equal to B squared plus F squared. And this equals to square root of 10 squared plus square root of 8 squared. The results that A squared equals to 18. And if we need a, we can do a equal to square root of 18. So let's now write the equation of this ellipse. We know that it is centered at the origin, so the general form, it's going to look like this: x squared over a squared plus y squared over b squared equals to 1. And now let's plug what we know. We have x squared over a squared. This is why I left this as a squared. It's going to be equal to 18 plus y squared over b squared. We have b squared is going to be equal to just 10 equals to 1. And this is the equation of this ellipse. Let's see, based on these results, we don't have any squares. The correct answer seems to be D. Problem number 2, plot the foci of this ellipse. So we're giving this ellipse situated with the center at minus. So the center is at -4, 3. So I know that the equation of this ellipse is going to look x plus 4 squared over a squared plus y minus 3 squared over b squared equals to 1. So now let's see. Let me assume we have the focus point here. I will draw the distance from this point on the ellipse to the focus point. And this is my focal distance. This is B, and I know that this is A. So the focus point is going to be equal to square root of a squared minus b squared. And I'm just using the Pythagorean theorem and all the things we've learned before. So we have to calculate A and B. Now, calculating A and B is just a matter of using the distance formula if you have the 2 points. So if we want to calculate B, looking at the distance B, it is a vertical distance. So the distance between these 2 points, it's going to be just the difference in the y coordinates. So B is going to be equal to 7 minus 3, and this equals to 4. So B is equal to 4. And let's see, A is a horizontal distance. So that means that the distance between these 2 points is going to be just the difference in the x coordinates. So I'll have 1 minus 4. I will get 5. This results A equals to 5. So in case you're wondering, why did I do y minus 4, which gives me a positive number? Why didn't I do -4 minus 1, which would give me -5? We know that a distance, it's always a positive number. So even if you get a negative number, the distance is always positive. So now we have B and A. We can calculate the focal distance. So focal distance is going to be equal to square root of a squared, which is 5 squared, minus b squared, which is 4 squared. And this gives me square root of 25 minus 16. And this gives me square root of 9. And I get that the focal point equals to 3. So now let's plug the coordinates. The center of this ellipse is -4, 3. So if you just look at the ellipse, so let's say you don't have the ellipse. Even if you don't have the ellipse, right here is pretty obvious. You go left and right. But if you don't have the ellipse, you know, the center is at -4, 3. And you know this ellipse is the major diameter of this ellipse is horizontal. because we got A greater than B. So this means that my ellipse looks like this, right? Because you get A greater than B. So you know the foci are situated on the major diameter. So if your center is at minus 4, 3, you know that in order to find the foci points, you have to move horizontally left and right. So you have to subtract and add the focal point from the x component of the center. So in my case, the coordinates of the ellipse is going to be minus 4, minus 3, I'll get minus 7, 3, and if I subtract, if I go on the right, minus 4 plus 3, I'll get minus 1, 3. So this is going to be somewhere here. These are the coordinates, which is minus 7, 3, and minus 1, 3. Minus 7, 3, minus 1, 3. The correct answer is B. Problem number 3. The equation of an ellipse is given below: x minus 12 squared over 289 plus y minus 3 squared over 64 equals to 1. What are the foci of this ellipse? So the foci of this ellipse is going to be somewhere over here. And we're just going to go straight to what we know and how to calculate the focal point. And this is B, this is A, and this is the focal distance. So we have to calculate the focal distance. And based on this drawing here, we have a right triangle. Again, focal distance is A squared minus B squared. So what's A and what's B? If we look at the equation, we know that the equation of an ellipse looks like this: x minus h squared over a squared plus y minus k squared over b squared equals to 1. So in this case, if we rewrite this equation, have x minus 12 squared, 289 is a squared, and I get 17 squared plus y minus 3 squared over 8 squared equals to 1. So we just know that B is equal to 8 and A is equal to 17. Now, when we plug this in this formula, we are still going to work with the squared. So we have A squared equals to, let me write it down in another row. So we do equals to square root of 289, that's A squared, minus 64, this is B squared. So I get square root of, let me do a quick math, 289, 64 minus of 225. And this results my focal point is 15. So again, what are the foci of this ellipse? We have to find the coordinates. We know that the center of this ellipse, based on this equation that we're giving, right, based on the equation given in the problem, the center is at 12 and 3. So now if we want to find the focal points, we also know that since A, right, since A is greater than B, that means that my ellipse is horizontal like this, and it's not the other way around. It's not, if my ellipse was like this, right, in this case, I have B greater than A, right? This is A, and this is B. but this is not my case. I have A greater than B, so which means that the major diameter is horizontal like this. So if I'm at the center, in order to find the focal point, I just have to add the focal distance to my x coordinate of the center. So I'll have to add 15 and subtract 15 to find the focal points. So the focal coordinates is going to be, let me just change the, so the focal coordinates are going to be 12 plus 15, I get 27, 3, and 12 minus 15, I get minus 3, 3. And these are the coordinates of this, of the focal points of this ellipse. So 27, 3, and minus 3, 3. It's C. The correct answer is C.